Good evening, guys. Today you're going to be on page 79. This is lesson 2.2, and we've got guided notes that are on the back of what you did the day before. So we finished this the other day. Now we're on 2.2 guided notes. And we're beginning in chapter 2 to introduce how to prove things and how to go through logical arguments and logical steps. So a lot of what we're doing today, you're not really going to kind of see the reasoning why. It's just kind of getting a lot of foundational vocabulary. It's really important that you read and follow along in the book as we go through this, and just kind of hang in there when it seems a little bit crazy or redundant. This is just building a framework for us to use to develop more logical thinking. So what I'd like you to do on page 79 is to begin by reading the definition of a conditional statement, and then we're going to fill this in. A conditional statement is a logical statement that has two parts. It's got a hypothesis and a conclusion. And we often use an arrow here. It's a shorthand notation for the if-then statement that we're going to develop. So a hypothesis and a conclusion. We often write this in the if-then form, and the if part of the statement is your hypothesis. That's what you are, that's kind of like your groundwork. If this is true, then is your conclusion, then you can conclude that. We often refer to this as an if-then statement. And the example in the book, if it is raining, then there are clouds in the sky. So the hypothesis is that it has to be raining for there to be clouds to be in the sky. That's the true conclusion that you can follow. So I'd like you right now, I've got 4 examples here. I'd like you to take a minute and try to put them into an if-then form. And you can pause the video to do that, and when you're finished, start it and we'll go through it and see how close you were. So go ahead and pause the video and try those 4. Okay, so what I'm looking for here is all 8th graders take U.S. history. The hypothesis would be if you are an 8th grader, then you take U.S. history. So check to see if you wrote that. I'm not going to rewrite it because of my finger. Number 2, if, and we don't want to say if you are a linear pair because we're not going to pretend to be angles. We're going to say if 2 angles are a linear pair, then they are supplementary. So if 2 angles are a linear pair, then they are supplementary. Same thing over here. We're not going to say if you are 9. You're going to say if x equals 9, then x squared equals 81. And number 4 is my favorite. If you are a Michigan State fan, then you are crazy. And we all know you could put many different adjectives in there besides crazy, but we'll keep it fun. So if you are an MSU fan, then you are crazy. So that's kind of developing that if-then statement. We'll have lots of practice with that. On the bottom of page 79, if you can please read and define the idea of negation. Negation often is referred to as just not or opposite. Whoops, I spelled that wrong. So the negation of I'm an MSU fan is I'm not an MSU fan, or the opposite of an MSU fan. So the negation of the angle is 90 would be the angle is not 90. The negation of the angles are vertical is we would say the angles are not vertical. And we're going to introduce this symbol right here. Looks like a similar statement, but that's just the symbol for negation or for not. Okay. All right, if you turn to page 80 at the top, verifying statements, it says conditional statements can be true or false. To show that a conditional statement is true, you must prove that the conclusion is true every time the hypothesis is true. So, if we can prove that people are crazy and they are MSU fans, then we would conclude that the if-then statement is true. Excuse me. Sorry, just sneezed. Excuse me. To show that it's false, you're only going to need to give one counterexample, and it would. So if you can find an MSU fan out there that is not crazy, you show them to me, it would make that entire statement false. I don't believe it can be done, though. So with these if-then statements, then we want to make 4 similar statements where we flip-flop the hypothesis and the conclusion. Okay, so this is going to get a little bit crazy for a minute, but the conditional statement is your beginning, and we often call it if P, then Q, and that's how we use that arrow notation. P is just a variable that stands for the hypotenuse, so if P is true, then Q is true. And P can be anything. So if you are an 8th grader, then you take U.S. history. So the P and the Q up here in this example, it's just variables that represent the conditional and the hypothesis. So here's an example. If a dog is a Great Dane, then it is large. So the P is the dog is a Great Dane. The Q is then it is large. Okay. If a polygon is an equilateral, then it is regular. Okay, and we know from last lesson that we need to have a little bit more than just equilateral. It's got to be equiangular as well. But we'll get into more proofs of that. Okay, then to go from this traditional conditional statement to the converse is you just flip-flop. The conclusion becomes the hypothesis. So it's Q then P. And we're going to learn lots of ways to remember these things. But here's an example. If the original was if a dog is a Great Dane, then it is large. If you flip-flop that, and if the conclusion becomes the hypothesis, it's in the converse form, Q then P. If a dog is large, then it is a Great Dane. So over here in this box, can you please rewrite this statement as its converse? Flip-flop those two. If you need to pause the video, do that. The next one is the inverse, and the inverse is not P, not Q. So back here our original, if a dog is a Great Dane, to do not P, it would be if a dog is not a Great Dane, then it is not large. And if you think about that, that would be true. If a dog is not a Great Dane, then it is not large. Actually, it can be true, it can be false. There are dogs that are not Great Danes that are still large, but that's how you rework it into that form. Please do the same thing here. Can you write the inverse of if a polygon is an equilateral, then it is regular? And the last one is contrapositive. Contrapositive is not Q and not P. So not only do you flip it, but you also negate it. So back up here, the original, if a dog is a Great Dane, then it is large. We're going to make then it is large the hypothesis, and we're going to negate it. So if a dog is not large, then it is not a Great Dane. So take a minute to see if you can write the contrapositive of the polygon is an equilateral, then it is regular. Okay, now we're going to have to remember all these different forms. And you just need to know that the conditional statement is really where you begin at. If you have the if-then statement, it's in P then Q form. We're going to do lots of different tricks on how to remember this, but here's a trick. This works for most people. If you think of the word Converse, I don't know if I'm dating myself, but back in the 80s and 90s, Converse were the big type of basketball shoe that everybody wore. So if you think about Converse, just think about switching your shoes. Your left foot becomes your right foot becomes your left foot. You're just going to switch your shoes. Okay. Inverse, if you think about inverse, think about when we talk about additive inverses. Isn't 5 plus -5 additive inverses? So when you think about the word inverse, if you can think opposite, so the inverse becomes not P, not Q. So that's the trick for remembering that. And the last one is contrapositive, and the best way I've come up with is notice that contrapositive is the longest word here. Converse, inverse, contrapositive. So there, it's the most complicated word, so it's got the most complicated stuff happening. In other words, everything happens. It switches shoes and it becomes opposite. So it's the most complicated switch. Okay? We're going to talk about this equivalent statements in class, but just to finish up, can you please read the perpendicular lines definition, and I'd like you to write the converse of that. And then to finish up, right at the bottom, we're going to talk about biconditional in class. But on page 81, can you guys please do at the bottom 7 through 10 in the guided practice? And that will be it. I know this probably felt a lot like an English lesson. We'll spend a lot more time talking in class, and I will see you tomorrow.